We'll move on to a panel, one of the industrial and societal panels, hosted by Scania. And this panel is called Perfect Road Traffic Information Powered by 6G, but what about privacy? And the development of cooperative intelligent transport systems where vehicles and other participants in the road system share information about their position and other data are paving the way for autonomous vehicles. But will business confidentiality and privacy concerns stop this vision? That's what this panel is about. I'll hand over to the moderator from Scania, the technology leader for connectivity, and his panelists, Ulrik Janesson.
Thank you so much. So I'm thrilled to be here and to have this important talk, and with two guests here physically and one online. I hope that you will also perhaps give us some questions. In the end, we'll try to address them. We'll see how that goes. So at Scania, we're working with the vision of creating self-driving trucks. And there are such clear benefits in this. Of course, efficiency to be able to do things better, faster, cheaper, but also safety. I mean, humans are not always the best drivers. At least I am not always. But this is a grand challenge, and it's really about a system challenge. And there are many hard problems that we need to solve in this. One of them is perception. So how do we get the vehicle to kind of perceive its surroundings and understand what is the actual situation? How can we get situational awareness? Professor Aude Bial was talking about this in another context earlier today that I felt was really interesting and good, kind of fed into this talk. We also had just now the session here before that is relevant. We'll get back to that. But sensors when we talk about self-driving, it's autonomous, and so it's sensors in the vehicle. The vehicle is supposed to be autonomous, but I think that there is a next step. We think that there's a next step. We also need to have sensors outside of the vehicle. And how do we do that? We have already today cameras on the roadside. We have probes of different kinds, cell phones, other vehicles, and so on. So we can use that. But the problem is that we have a very low coverage with these sensors. So we don't get enough information. It's kind of expensive and hard to deal with those. So therefore, today we want to talk about an exciting technology and the implications of it. So what is being discussed now in the 6G telco generation, there is a technology that is called joint communication and sensing. Basically, this is about equipping the telco networks with a radar-like capability. And so you put radars in the cell towers, and then you can detect your environment. You can detect pedestrians, you can detect bicyclists, maybe even dogs, small things like that. And this is not reliant on having a cell phone. So it's standalone in that way. And also, potentially, we could have good coverage. So this, if you come trying to crack that big challenge of self-driving, and this is a dream come true. But also, of course, how do we deal with the privacy aspects of this? This could be really tricky. And this is what I want to talk to you about today. I'm going to you know from looking at the screens here who I have in my distinguished panel. So we'll jump straight into the questions. And I want to start with you, Christian. So you work at Carmenta Automotive, and you're already today, one could say, operating a digital twin of sorts. And just can you just give us a rundown? What can you provide today? What can we do today, and what do we do today?
Yeah, so what we bring from Carmenta Automotive is a software where we collect data from all the vehicles that are connected, but also from the outside world, and bring that together in one, could call it a common operational picture or a situational awareness view. And that is the digital twin in real time that tries to combine all the information that you have. And as Ulrich says here, it's clear that there are gaps. We need more information, and how can we deal with that? But already today, we are in a position where we have a lot of data that can actually bring you a lot of insights on what's happening in the traffic system, on the roads, around the vehicles, in order to provide a safer journey, for the normal vehicles with drivers, but also then into the autonomous world with self-driving vehicles. So looking into the future and seeing that there will be a possibility to get even more detailed information in real time, that is really exciting.
Thank you. I too think it's really exciting. And turning over then to you, Valentin. So this is where we are today, what Christian describes. But what can we expect from tomorrow? So what and when can we expect this specific technology, 6G joint communication and sensing?
Yes, so joint communication and sensing is a very exciting technology that promises a radar-like capability for spatial monitoring. So you would get this crude image if you're using high frequency of transmission communication, and then you can obtain resolutions down to centimeters. So in a way, you could detect all the entities that you have mentioned in your original presentation. So it's not the same.
There's a but here. I can hear it.
There's always a but with technology.
Yeah.
Yes. So when I mentioned an image, it's not the same image you would get from a normal camera. So you're not getting the same thing, but you're getting some interesting properties that maybe you wouldn't get with a normal camera. So you would be able to obtain the location, the position of an object that you're trying to monitor. You can obtain their velocity, which is an important thing for the automotive use case. And you have other interesting properties like sensing in the dark. So you wouldn't need an external source of light because you're using radio waves. And on top of this, you can also work in rain and fog, but with a diminished effect because the small particles of water in the air will diminish the efficiency of the unit. And now what we're getting today is like insights from testbeds run by the academia. And we are getting these like indoor use cases of what communication can offer from a sensing point of view. But going from there to like large scale, worldwide, interconnecting joint communication and sensing, we need much more research and much more standardization to do so. The standardization work has not started yet, except discussing some interesting use cases there. And what we envision actually is that when the technology will come, it will come probably in some specific scenario. Private networks running in harbors, running in industrial settings, with specific requirements and specific properties in order to say and to develop more this technology. And when talking about these use cases, besides the technological aspects that needs to be solved, we have also the business aspects that needs to be solved. So all the stakeholders that participate in this ecosystem and would want to use these technologies need to sit together and mature the business models. So that's the next step that we can do. So it's a very, very exciting technology, but we need more proof of concepts, more research, and an ecosystem effort in order to see what we can do with it and how it will complement the already existing sensors that we have in vehicles and in infrastructure.
Yeah. All right. So we talked a little bit now about what we have today and what we can see with this technology in the future. And now let's turn to you, Katarina. What is legally accepted today, and how can we extrapolate that into the future and kind of understand what would we need to do here to protect ourselves in the future?
Yes, what I think we need to do today is, first of all, follow the rules that are in place, as you say, which is, I mean, since this is at a development stage, there is a need to include the privacy by design and by default, which therefore we need to make an analysis, which will also sort of, which we need to follow up in the future, and also which cannot be done simply by the developer, is also what kind of legislation would we need to put in place in order for this to work in a sustainable way and relying on human rights and privacy.
And what I liked also was something that we talked about earlier when we kind of prepped a bit for this talk. The fact that, of course, all of this exists in a context.
Yes, for sure. And I mean, then we can just go to human behavior, because the technology in itself does not have to be sort of dangerous in itself or sort of developed for those kind of purposes. It's also the fact that how we behave as humans, and then there is a concept from sociology, which is the phenomenon of function creep, which means that we're just going to continue and try, we can, if I have a camera here, I can see during the light of day, but then what happens, I would like to see what happens at night, I would like to see what happens around the corner, and just in case. This is a tendency that we need to sort of put some strains to, and that is why it is so important with the human rights perspective and the privacy issues and the data protection principles.
That in a way actually ties into the
Yes.
previous talk here that we had, this
and
function
with the
creep.
combination that we will also like to use a combination of different technologies. So what if I can detect faces with this technology? Can I also use facial recognition technology in order to identify more accurately the persons or the people who are walking or being in the street? And we can use that for all kinds of surveillance purposes, whether it's private surveillance or mass surveillance by the state. Because that is also the danger today, is that it's not only the state, which we has put in place so many regulations for to prevent the state from surveilling us, but that's also the private surveillance going on. So there are all kinds of different issues here related to that.
Mm. Okay, so we set the scene here a little bit. What can happen and what can we do? But if we allow ourselves to be a bit creative, and we have this future technology, it could identify either a kind of a blob that is moving in the cityscape, perhaps, once we have introduced it in the cities rather than in enclosed areas. But it could also be much more fine-tuned than that. It could be not a blob, it could be you could see if it's a small or a big person. You could see if it's a woman or a man, potentially, by the outlines of it. You could maybe even use it for facial recognition, although that's extreme case. But yes, in an extreme case, we have centimeter accuracy, and then maybe you can recognize a face. So what should we do about this? I mean, if we start with you, Christian, I mean, you deal today with sensitive cases. I know that you have emergency vehicles and so on. How do you handle it?
Absolutely, and first, fully agree here with Katarina about the using and having privacy as a requirement from the start, and the problem with feature creeping and so on is obviously something that you need to handle. And we from Carmenta's side, we are used to building systems with our software within the emergency response system with ambulances. We have background in the military with defense system and in military intelligence and so on. So handling the information that is the system is built to deal with, that is something that is very important. And there are standards and there are ways to do that. And I think it's very important to define the use case, define what is it that we need, that we want to achieve, the target with the system that we build, and using that information. And for the traffic system, it's very clear. It is the vision zero. It's avoiding accident and fatalities. And by starting with that, then you can design the system. Okay, what is justified to use? What kind of data? What kind of data do you need? We don't need to know who is there. We need to know that there is an object or something. We need to find anomalies or interesting insights from the data, but we do not want to know who is there. So by stating that from the beginning, you can also design the system with this privacy by design from the beginning, and avoid getting into scenarios where you have the feature creeping and start to use the system for something else that is not intended to from the beginning.
Yeah. But let me kick back there a little, push back a little bit. So I could imagine the argument coming from Scania's side, saying, hey, no, we're designing autonomous vehicles. We need to kind of predict what is happening in the traffic situation. And it's just really, it's very, very different if it's a little kid, 10 years old, or a kid that is 3 years old, or a teenager, or a grown man, or a grown woman. That they all behave very differently. So it's reasonable to get to want quite a lot of information. But of course,
and that's why the cooperation between the different departments or professions here, like Katarina is stating here, with the legal perspective on this, that is something that you take into account from the beginning, and that helps you to avoid those kind of feature creeping that you're talking about here, I think.
Valentin, Katarina, comments on that?
Yes, I would like to comment a little bit on that, because I think that's very promising sort of development that you're talking about, that we don't have to have information about who is there. But I'm just thinking that we might find a need to be sure of who it is. If there is an accident on the road, if there is a crime being committed, we will want to know what is behind those persons that we are detecting with this technology, and I would assume that it would be used for those kind of purposes, because it would be so important if you wouldn't find another way around it. So we'll have to find a new balance there on how to handle this. But there will surely be sort of calls for revealing the identity of these individuals that you detect with the technology. And then we need to make sure that the legislation in place will cover those situations. And we have to be also very realistic with how humans behave normally and what we will want to know. But we will have to make sure that we have procedures and legislation in order to prevent any misuse of this kind of information.
Yeah.
So that will be the most important thing, and especially we also have to be at the international level.
Yeah.
If this will be used as this sort of mass scale.
I mean, Katarina, you are our law woman here today, and the strength of regulating is that you can kind of build into proportionality, like is it reasonable, all of these considerations. So that is the strength. But of course, it is also really important how you enforce the law in the end, and there is a weakness there. So we
and
want
how
to
you use the systems. For example, I think that if we use a combination of different technologies, yes, of course, perhaps that could be covered by the law, but we don't know if the legislation in place is enough. So it's also a question of how we apply it when it is in use that we need to think about. So it's the development phase is very important, but that's sort of limited in many ways because you can't cover all the situations. So we need to think about both ways. So I think it's important that lawyers and also politicians get involved in these kind of thinking now instead of waiting until it's already rolled out and in use.
Yeah, but me, I'm born and raised a technician, and so I want technology to save us here. So. Valentin, can you fix this?
We try to.
Good.
Or at least that's our intention. So in order to complement laws and regulations-based privacy protection, we need to come from the industry best practices, and we need to have technology-based protection. So we need to employ new technologies, privacy-enhancing, privacy-preserving technologies in order to ensure that the technological or the technical processing of the data captured by these new technologies are done in a proper way that are fulfilling all the laws and regulations. And then we are extracting only the information that is needed for a specific application, like the ones that were mentioned here. So here we have a trade-off between privacy and utility. And by moving the slider from one to the other, you can obtain more of one or more of the other. So then you need to see for a specific application, where are you there and what do you need for privacy-preserving safety, for a reason, if something like this exists.
Yeah.
But it's an ecosystem, again, I mentioned this again, and we need to work together towards this. Laws and technology and application developers need to work together towards this goal.
Yeah, for sure. And my original thinking was how interesting this is in the really difficult situations. So it was so good when you said that. Maybe we start with the lower hanging fruits. Maybe we do easier situations, not only technically, right, but also to deal with the ecosystem. And yeah, I really like that. I mean, again, the privacy by design. Can we get further than just saying, you need to trust me. I deal with this data. I will do it in a good way. Can we somehow make the data be in the control of the person who would be affected by it, or the people on the streets or something like that? Is there any way forward there?
That's an interesting question. I mean, if you're thinking about the normal user that browses a web page, then you get all these pop-ups, all these banners asking for your consent to use data for specific purposes. And if you're thinking that you're walking down the street and you're exposed to a new technology, what would be the channels or the ways in which your consent can be given or withdrawn to participate in a specific application? So that's an interesting question that needs to be solved with all these new technologies that are coming in.
And we talked earlier about the right to be forgotten, right?
Yes, exactly. And maybe that would be a little bit difficult here to use those kind of, for those rights to be applied. But I think the right to information is very important. but of course, it's difficult to say that. Should I say that I withdraw my consent and then a vehicle might hit me? Maybe we will not be able to consent to such a thing with all what it means. So I think the consent will be difficult to use in these kind of purposes. There will be probably more legal base to have some public interest and the right to life, for example, the rights of others. So I think that there will be a little bit of difficult to use that kind of legal basis for this kind of monitoring or surveillance.
But it's also about not storing data that you don't need to store,
Yes.
because a lot of what we're talking about now is the real-time information that can be important in order to detect things and avoid accidents or things like that. Then you don't need to store that data. So that's also a way to see it. The legislation is very important. That can help in this, but you can create systems where the data is useful, but it's not stored and it's not there after it's been catched. So that's also a way to handle this when you cannot give consent or ask afterwards to delete all my data.
That's I guess, a pretty natural kind of extrapolation from the legislation we have today with cameras, where basically you cannot save the picture if it's not clear that there was some kind of you were speeding or whatever with your vehicle. So that's interesting. I feel that there might be questions from the audience.
Yes, a few of you have asked questions. So the first one is, why are we talking about 6G when we have challenges with implementation of 5G?
Well, I chose the subject here, so I guess I'll have to take on that one. Of course, there's a lot to explore in 5G. And I mean, you all know, 5G is a family of many different things. So it's not like you have 5G, you have parts of 5G, and 6G even more like that. There are loads of things to explore and discuss and think about when it comes to 5G. But
when we say 6G is when we think we have true connectivity, that's really the kind of a technical environment where autonomous vehicles would be able to be operated, or is that why we're forward thinking?
I think why I wanted to bring up this specific one is because of the problem. We need information, and we get information today about what's happening in the road system, but the coverage is low. We need better coverage, and that is why I think that JCAS, joint communication and sensing, is very interesting technology.
Mm-hmm. And this is a big one. How do you think we can keep the pace of ethical and legal framework development as technology advances so rapidly? What is it that we must not lose focus on?
Now I'm happy I have my experts. Guys, what do you think?
Well, I definitely think that is very important, but I think that lawyers has to work alongside the technicians in order to make this real and to detect different legal issues immediately and try to find different new solutions, because we might need new legislation. Not necessarily, but probably we're going to need to have more specific legislation when it comes to this kind of technology.
You raised that issue earlier, Katarina, that politicians, legal professionals and policymakers need to learn more. What is it specifically that they need to learn more about in order to really participate in this kind of these kind of discussions?
Well, I don't think we necessarily need we need to learn about the technology, but we can never get sort of in depth, of course, for natural reasons. But I still think it's very important to work together and not just working experts in their own teams and more isolated. I think it's very important to work together because that's how we can find sustainable solutions.
Anyone else wants to add to how we keep the pace of ethical and legal framework development? Christian?
Katarina is completely right there. It's working together. That is the key to that, I think, and it will be a challenge, but important.
I'll do one more question, although we're a little bit over time. How do you suggest to do a privacy risk assessment in a systematic way, in particular considering privacy by design approach and the utility privacy trade-off?
That's a heavy question, and I don't think we can take the answer very quickly. But
what is the question about?
What is the question about?
Yeah.
How do we assess what are the privacy risks with this technology? And I think there are multiple views to take in here. And I mentioned ecosystem a lot of times. So if you're simply looking at the technology, you might see some privacy aspects or some technological aspects. If you're looking at the applications that could run on top of them, you see other privacy aspects. If you're looking at the ecosystem and how these applications would work together, then you might get even a more, I won't say complete, but a more complex picture of what is there. So again, we need to look at this technology impact, particular and technology in general, from different points and see what are the benefits, what are the trade-offs, and how can we make it better so it's useful for us.
I want to thank the panel at this point. I think it's so interesting that we start with the title, which is Perfect Road Traffic Information, and then you end up with all of the different aspects of the digital society, all the privacy aspects, the legal aspects, the ethical aspects. So a warm hand to our panel. Thank you so much.